And welcome everybody to the Daily Space Weather. Lots of stuff to cover today. We're going to blast through a lot of information as there's lots of stuff going on. Coronal mass ejections, for example. First thing to do is take a look at the sun here in 171 angstroms and colorized magnetogram. And I would direct your attention to this area down here at the bottom of the screen. That's where actually two coronal mass ejections happened. And we made a video about it last night because I noted it. So I made this video right here. And this is the one that is expected to miss the Earth to the east. There was another one before that expected to miss to the west. And so if you haven't checked out that video yet, check out that video. It is on the YouTube and BitChute pages. There you can see that easterly, and there's the westerly coronal mass ejection. Now we looked for stereo A imagery and we could not find it. Perhaps stereo A experienced a CCD bakeout. That's my best guess, as we don't see the data. So I did a pretty exhaustive search there to find the data from stereo A, and it's just apparently not there. So we're actually on the stereo website here, and we did various different browses of the data, and we don't see that coronal mass ejection from the perspective of Lagrangian 0.5 at stereo A. So I would show you the imagery, but it does not appear to be there yet. So here are some helioviewer movies for you. This is the degradation of Sunspot 2803. This is the magnetogram of that area. Sunspot 2803 has shrunk. It remains an alpha class sunspot. Best guess is that this one is evaporating based on what that magnetic data looks like. And well, you've got shrinking umbrae, so what else can you say? They are spreading apart. There is still some possibility of solar flares. Here's that same view in 171 angstroms. And there still are plenty of plasma filaments out in the corona right now. We'll show you all of that a little bit later in the video. Sunspot 2803 in 171 angstroms, ionized iron. And most of the UV emission spectra that we look at are ionized iron, if you're wondering. Here's another one. It's 94 angstroms. And you'll see a great view of this coronal mass ejection down in this area. You can see that filament right at the beginning of the video right there. That filament released. And it was sort of a two-stage coronal mass ejection. And here's one more image. It's 131 angstroms, and we've got close-ups of that. We'll save most of the rest of the solar imagery till the end of the video. At least the SDO imagery. It's been a busy 24 hours for solar activity. All right, what else do we have here? Here's a diagram of the planets. And we've got a planetary pile up in the sky. We'll show you on the next slide. That's where things are now. And notice how we've got all these planets in a line. Mercury, Venus, Jupiter, Saturn, and former planet Pluto. Wait, has it been reestablished as a planet? I can't remember. In any case, if you're up before dawn, you may see this pile up. You may see Saturn and Mercury and Jupiter and Venus all in a very small portion of the sky. I have no idea if we have clear skies here or not. It's going to be too light for me to check. The 10.7 centimeter radial flux has popped up to 76. A welcome sign, a bit of an increase in solar activity there. The radial flux, a measure of the sun's coronal and upper chromospheric radio output. And there's, excuse me, I think I inhaled cayenne pepper. There is a 1-year context of that. The red line is the sunspot number, and the black line is the radio flux. And we've seen this ongoing geomagnetic storm for the past 2 days as those protons from the coronal hole in the south portion of the sun arrived a bit early. So you may see all kinds of different alerts and so on coming out. Geomagnetic unrest. Let's talk volcanoes. Etna has been erupting periodically in 35-hour intervals. Not 24-hour intervals, folks. 35-hour intervals. And there's the latest one. Another paroxysm happened yesterday evening on February 20th. So that's 4 paroxysms in little more than 4 days. Paroxysms are things like lava fountaining. And I know some towns were covered in ash and so on. What causes such regular eruptions, folks? It's really not known. I'm asking because I actually don't know. Klyuchevskoye now back on the list of erupting volcanoes on the Kamchatka Peninsula. A new eruption started. A fissure at the northwestern flank at relatively low altitude. New cinder cones forming around the new flank vents. And lava flows at the surface seen on satellite imagery. Suwanosejima, near Japan, exploding. Flight level 050. It's a 5,000-foot ash plume. Mount Manam in Papua New Guinea, 20,000-foot ash plume there. Popocatépetl has dispersed its ash onto Mexico. Pacaya exploding. Flight level 100, it's a 10,000-foot ash plume. Fuego exploding. Flight level 140, it's a 14,000-foot ash plume. Sangay exploding, 22,000-foot ash plume. And we're unable to detect whether or not the Peruvian volcano Sabancaya is erupting. Please do not attempt to pole vault the caldera. Next, earthquakes. And we did see a 5+ magnitude off the coast of Oregon. We'll get to it. Looks like some deep quakes happening here, such as this 4.6 happening yesterday at Papua New Guinea at a depth of 150 kilometers. Here's another deep quake at Indonesia. So there's 2 deep quakes happening yesterday, right around when we premiered our daily space weather video. Extremely shallow quake at Hawaii, most likely underneath the caldera of Mauna Loa. That one happening at 600 meters above sea level, a depth of negative 0.6 kilometers. And here's this 5.1 happening off the coast of Bandon, Oregon. We'll show the location of that. There's a location of that 5.1 magnitude quake and a bunch of aftershocks associated with that as well. Here's another deep quake in Indonesia. That 4.6 magnitude quake near Indonesia at 164 kilometers depth. Some small deep quakes in southern Alaska. Here's one in western South America at depth. Here's one in Chile at depth. Those both in the mid-4 magnitude range and about 150 kilometers depth. Another deep quake at Fiji. So it's officially a deep quake event, folks. Lots of deep quakes kicking off here. A 4.8 at Fiji, 539 kilometers. By the way, this Smash stream was brought to you at twitch.tv/smashamash, a fantastic streaming platform. Thanks to our followers over there at Twitch, twitch.tv/smashamash. They've got a great mobile app as well. Thanks to our patrons, a true source of funding for the content, as we make just this side of nothing to make these videos on YouTube. So please press like and subscribe. Don't be a freeloader. Perhaps consider becoming a patron. Patreon.com/smashamash. Thanks, patrons. You are the main source of funding, increasing the probability that these videos will continue to be free, publicly visible, and existent. Look for our marketing to change. We've already received our stickers featuring this awesome design here. So look for more information about that coming out soon. Check out our own website, smashamash.com. You can find us on all kinds of social media. And our video from last night appeared on a couple Facebook locations as well as on Twitter. Twitter.com/smashamash. Check out our merch shops and our forum as well. Smashamash.com, our own website, as we saw the writing on the wall years ago. things like the self-destruction of big tech. And if you're viewing on YouTube, please press like and subscribe, press the notification bell, and don't forget to share the content on your social media. We need your assistance to get our content out there, as the algorithms have been less than helpful. We're also on BitChute, thanks to our new subscribers over there, as the subscriber count keeps growing. And we're going to do a short cosmology segment today, again, because there's so much stuff going on. So the first thing we're going to do is take a look at some cosmic ray monitors, as cosmic ray monitors are kind of important when it comes to cosmology. Also, in terms of geology and meteorology, cosmic rays figure in. So here's the Apatity neutron monitor, and you can see a significant downturn there in the last 30 days at Apatity. At Barentsburg, we did see a spike here a couple of days ago on the 19th. Otherwise, a slight downtrend there at Barentsburg. Let's check Athens, Greece. We'll go south and then even farther south. First Athens. And there's Athens over the past 30 days. A pretty flat graph there at Athens. Next, Mexico City. Going even farther south. Pretty flat there at Mexico City. And you can see that spike also on the 19th. That looks like a legit piece of data there. Cosmic ray spike happening at Mexico City. Let's talk about the center of the galaxy. The center of the galaxy is a complicated place. It features lots of strong magnetic fields, a lot of molecular diversity, extremely high cosmic ray flux, as well as extremely high radiation levels. Interesting article here on phys.org in the Astronomy and Space section. Cold dust cores in the central zone of the Milky Way galaxy. The central molecular zone, which is about 1,600 light years in diameter, from the Sun, which is about 26,000 light years away from the molecular core of the galaxy. I'll just let that scroll. If you'd like to read the article, feel free to pause the video. We'll be here when you get back. We're going to pick one random object here very quickly. A number between 1 and 1031 on our quantum random number generator is 880. Let's see what that object is. Number 880 is Maxi J1932 plus 091. No idea what it is. It is certainly an X-ray source. And you can see some pretty dense outputs here in the past few days. Probably a star within the Milky Way galaxy. I'm not sure what the Maxi catalog contains, but we don't have any links here to Simbad. Let's just take a look at one of the only known cosmic ray sources, Cygnus X3. And check out its X-ray transients. And there is the X-ray loud state. It looks like it's actually dropped off a little bit there. There it is. There's the 30-day chart. And Cygnus X3, one of the more interesting objects in the entire galaxy. The star Deneb, the brightest intrinsic object visible from this location in the Milky Way galaxy. I'll show you a quick image of that on the Chandra. In other words, in X-ray. It's a very bright object. And if you want to read all about Cygnus X3, which is actually the celestial pole star at the other end of the precessional axial tilt wobble cycle, head to smashomash.com/forum. There's a cosmology forum all about, a forum specifically dedicated to this high-mass X-ray binary, Cygnus X3, and that's today's cosmology segment. Let's move on through data because there's lots more stuff to cover. We don't see any significant solar flaring, no surprise there, as Sunspot 2803, the only sunspot on the Earth-facing portion of the solar disk, has degraded. We don't see any proton strikes, an indication that we were correct about the coronal mass ejection. Coronal mass ejection, two of them apparently not Earth-facing. Next, the real-time solar wind, which has been all over the place over the past 24 hours. We see these fluctuations here in the density between 12 and about 7 protons per cubic centimeter there. A very odd signal there coming from the This is from the Discover. And the solar wind speed made it all the way up to about 610. There's a reading at 613 protons per 613 kilometers per second. Current conditions are about 555 kilometers per second for the solar wind speed. Solar wind density at just over 9 protons per cubic centimeter. And here you can see many, many hours of geomagnetic unrest. Those yellow bars are representative of 3 hours of geomagnetic unrest. And let me check the life of the stream real quick. There we go. So yeah, we've been in geomagnetic unrest consistently here for 18 hours, which is the longest period of geomagnetic unrest in cycle 25. So welcome to solar cycle 25. Here is a magnetosphere movie showing this continued high pressure zone in the magnetosphere as that coronal hole wind stream arrived early. Will it depart early as well? It doesn't look like it so far. In fact, it was expected to subside originally today, but the high-speed coronal hole wind stream continues. So that's 4 hours of data courtesy of the Space Weather Modeling Framework, and this data is posted by University of Michigan. Here are ground magnetic perturbations, and we've seen some interesting auroras. We'll actually show you one photograph of that momentarily. Some major perturbations there over the Canadian North Geomagnetic Pole. We've got 2 North Geomagnetic Poles right now, as we're seeing a significant geomagnetic excursion going on. Also magnetic perturbations there around Antarctica, south of South America, as well as in the southern Indian Ocean. If you need to watch that again, feel free. Again, we'll be here when you unpause the video. So here's some of the pink auroras that we saw, sparked up by this coronal hole wind stream. Not sure where that one's located, but you can find all the information about that on spaceweather.com. Here's the auroral 30-minute forecast. It doesn't look like we were expecting anybody to see auroras in southern Australia or Tasmania, but it looks like some significant ones there over places like northern Europe. I would expect to see some kick up here over Canada as well. Surprisingly unsymmetrical auroras there. That's the Aurora 30-minute forecast. Here's the spiky readings on the GOES magnetometer. And again, there's lots of plasma, high-speed plasma no less, coming out of that coronal hole wind stream. That's the last 3 days as measured by the GOES 16 at the F ionosphere layer. And we're seeing pretty low readings happening here still. Expect to see a little higher readings here. We may see this graph expand. I think it's already expanded to 140 nanotesla. And let's take a look at the heliospheric current sheet. Keep in mind this data is 1 hour and 20 minutes old and can change suddenly. When the Earth snaps across into these more direct potential field force lines, as you can see here, expect to see higher readings on the GOES magnetometer. And the top view ecliptic plane field plot is one of the ultimate pieces of data that we have. It's derived from about 51 ground-based magnetometers here on planet Earth, as well as magnetometers at Lagrange point 5 stereo A and Lagrange point 4 stereo B. Here's another view of the same data with a different perspective. It's a line of sight field plot. You can see that coronal hole rotating well out of the Earth-facing zone. And you can see the sun's B field being pulled up in this direction. The sun's B field shown in blue here. This also shows the poloidal fields. North in green, red is the south. Here's the coronal hole field plot. Keep in mind, folks, the magnetic environment can change suddenly with absolutely no known warning. And remember, folks, in science, just because we don't know how it works doesn't mean we can't figure out how it works. It's part of the reason why some of us immerse ourselves in the data. Next, the coronal magnetic field plot. Let me just check the stream once again, and it looks like we are doing good. Thanks for leaving comments. Precious Lights Precious Light says KP affects cardiovascular systems when it's high. Sunday blessings to you too, Precious Lights. And yes, geomagnetic unrest isn't really what we would consider high. A KP of 4 isn't really what we would expect to see. An increase of things like mental illness, strokes, heart attacks, really anything associated with the nervous system can be affected by very high global geomagnetism, more so at the poles than at the equator. And you want to see like a KP more like of 7 for those health effects to really kick in. It's a fairly known thing. But thanks for commenting anyway. So here's the coronal field plot. It's the plot of the sun's atmosphere. It shows you potential field surface source lines in black or purple if they're open, depending on their location. Closed potential field surface source lines in pink. It's a chaotic place. Let's move on. Here's a diagram of the atmosphere. If you need to pause this, feel free. We show this because the F layer is where the GOES 16 makes its measurements, and the GOES 16 is one of the most important satellite data sets we use. Also, here's a diagram of the Van Allen belts. Keep in mind that the altitudes here are in miles as opposed to kilometers. And I would direct you to this article on space.com. So there's this great article here on space.com which tells you a little bit more in depth into what's going on in terms of the atomic composition, the plasma composition of the inner versus the outer Van Allen belts, and they are quite different. And without going further into that, the radiation belts contain more than electrons. So anyway, check out the article. The title on space.com's article here is Van Allen belts, Van Allen radiation belts, facts and findings. So perhaps have a read on that one. It's fairly current. It's from just under 3 years ago in May of 2018. So continuing on with things like electron counts and charging hazards. Here are the charging hazards, and we see some significant ones here over the Central Pacific, as well as Mexico. And we've actually moved into electron storm levels. So here's the GOES electron flux, and you can see we're well over 1,000 pulse flux units. Somewhere around 1,300 pulse flux units, I believe, is where that is now. So a surprisingly high level of electron flux despite the coronal hole wind stream continuing. And if you're wondering, I was incorrect about the electron flux forecast. So if you want to be correct about 99.5% of the time, follow our channel. And basically, the reason I was forecasting low levels of electron flux is because coronal hole wind streams are typically associated with a cratering of the electron flux. So now we have this uptick, lots of electrons out there at the ionosphere layer. Here's the 1-year chart of that. And it's not super high levels here. As you can see, this is more like an electron storm up where my pointer is up here. We're at more moderate levels, just enough to get into what we call electron flux warnings. So expect some GPS errors, especially if you're around the equator at noon. And here's a visualization of the total electron content. This is like the inner Van Allen belt, essentially. And we see some anomalies there over Antarctica. A pretty disorganized total electron content here, and some major errors happening right where we see those charging hazards over the Central Pacific, the Central Eastern Pacific. I'll let it play through a second time. And you could see GPS errors of 1,000 miles, 1,200, 1,500, 2,000 miles of errors in your GPS. Here's the total electron content forecast model. And we're expecting even higher levels here to get well into electron storm levels. I won't argue with the forecast this time. We're expecting the coronal hole wind stream to subside at any moment. But there's the 3-day forecast, which is those green squares. The diamonds are the observation. And you can see NOAA agreed with me that we're going to see low levels. So we saw some anomalously high levels of electron flux. Here's a map of the ionosphere. Ionosphere looking a little bit anomalous here as well. So a lot of things coming together at the same time, folks. Coronal mass ejections, coronal hole wind stream, ionospheric anomalies, electron flux, electron storms. Part of the reason we have a channel. And that's a full day worth of data. Here's the latest image. And we're coming at you a little bit late today. That latest image at 12 o'clock Universal Time. Looking pretty normal there. And we expect the highest frequency to be just behind where the sun would be located around noon, which is someplace around there, as we're just almost exactly a month from the spring equinox. Next, looking at the jet streams, we're moving into meteorology segments here. And we're on nullschool.net looking at the 250 hectopascal winds. And check out how chaotic the jet streams are in the southern hemisphere. All over the place. So here are the jet streams of the Western world. We show it daily. And look at the extreme meridional jet stream flow. Looks like some very hot weather there in central South America, as equatorial air is sent into the central summer portion, places like the northern Atacama Desert. And check it out, we've got a jet stream reversal right here. Jet stream blowing east to west over the eastern Pacific, as well as extreme meridional jet stream bends right here, blowing south to north. And we're expecting a Saharan dust storm actually in Europe. And it's all got to do with this almost due north jet stream flow. A Saharan dust storm expected to spread over Central Europe, followed by unseasonably warm temperatures, where alarmist news sources who know nothing about atmospheric physics will try to tell you that the planet is warming because of tiny spikes in warmth. So check out this. Jet stream blowing backwards over the western Pacific once again. Stagnant jet stream here over the Indian Ocean. And you can find that yourself at nullschool.net. It's the 250 hectopascal winds. Here's a real-time lightning map. I like to use lightningmaps.org. And really, we're seeing a lull in lightning here over the past couple of days. One errant strike there, it looks like, happened over just south of Lincoln, Nebraska there. Very low levels of lightning. It looks like one just struck in southern Portugal. Here's a pressure map. And now we see low pressure dominating both polar regions. So we've got low pressure all in this area, small pocket of high pressure, and then low pressure over the entire South Polar region. And we'll advance this into tomorrow. This is where the Gfs Forecast puts pressure cells at 12 noon tomorrow. Extremely concentrated and irregularly shaped low pressure system over the North Atlantic, as well as central Canada there. It's a double. High pressure still off the coast of California, and really over the entire western portion of the country. Let's continue on with more meteorology stuff. Here is what's going on in the cloud layer. It's too dark to use the visible satellites, so we use the NASA GOES Interactive Weather Satellite GOES East 3.9 nanometer wavelength. It's shortwave radiation. And since water emits radiation, this system is able to guess where clouds will be, even when it's too dark to see them. I would note all the low clouds over the Gulf of Mexico and western Atlantic there. Massive amount of low clouds there. Here's a water vapor map of the same region. There are the clouds again, and there's water vapor. Again, temperatures finally kicked up in Texas. Hopefully everybody's plumbing is getting fixed promptly. A little bit of moisture approaching Lake Superior and Lake Michigan there, as you can see on that water vapor map. Next, U.S. Doppler radar map. And we see some snow showers associated with that moisture in places like Iowa, Nebraska, southern Minnesota, and eastern South Dakota. Thanks, Smash Team, for tuning in. We've got bonus features. Also, don't forget to press like and subscribe. Thanks to our new subscribers over on YouTube, youtube.com/smAshomash. Check out our playlists as well. We just created another one, meteorology segment, for when we make more meteorology videos. There's only one video in there now, but follow the playlist perhaps. And don't forget to press the notification bell and press share. Share with your friends, your foes, your science noobs, and science pros. Here come bonus features. Here's what Sunspot 2803 looked like when I did show prep. And you can see those umbrae, very small and weak. They look like they're degrading. It's been an alpha class sunspot the whole time. Likelihood of solar flares has actually dropped. And let's press refresh before your very eyes. And there's the current state of affairs. It's actually degraded as we made the video. So you can see it's actually shrunk just in the few minutes that we spent making the video. Let me move that up a little bit. And the only umbrae there are North Pole oriented. Let's close things out with some more images of the local yellow dwarf here. So let's go back to 304 angstroms. Here's 171 angstroms. You get a different wavelength view of that coronal mass ejection filament eruption. Once again, folks, another example of the fact that we don't need to see sunspots or solar flares for coronal mass ejections to happen. And these just missed Earth on both sides, or will miss Earth on both sides, according to all data that I see. Here's a close-up of the southern hemisphere. This is 131 angstroms and 94 angstroms combined. And these two wavelengths actually take more images per minute. So these take 10 images per minute instead of only 2, giving us a higher temporal resolution. I decided to combine those there for you. Great view of that filamentary activity. Here's another composite. This one includes 211 and 171 angstroms. There are still some plasma filaments on the sun. They didn't all erupt. Some of them remained in the corona. There is still a possibility for coronal mass ejections. I'll continue to give it about a 50-50 chance of more coronal mass ejections happening. It all has to do with the magnetic anchoring of those filaments. And you can see that large coronal hole there rotating toward the southwestern limb. We may need to make more videos as a result of that today. In any case, thanks for tuning in, folks. Remember, stare at the sun, don't drink, and if you do drink, don't drive. And since it'll never be now again, welcome to the Neo-Renaissance. May that solar wind be at your back and that covidiously absent from your doorstep.